Okay, today we're going to continue on the same subject of last lecture, which is transportation project metrics. And basically, what we mean with project metrics, it's basically a measurement. Project metrics are measurements for the project's progress, performance based, okay, on the project goals and critical factors for success. These metrics can be classified into two major categories. The first category, which is value-based metrics, that means a metric that measure things in monetary values, or benefit-based metric, which measure the benefit of a project, for example, like safety projects, saving human lives, saving injuries. These we cannot put monetary value on. Project metrics used to measure project success. So what are the key attributes for the parameters involved in building a project metrics? First of all, these parameters must be relevant to project objectives and directly related to project objectives. Okay? It should be quantitative values and supported with real data. That means it's not qualitative values, okay? Because qualitative values are subjective, but quantitative, that means it's a number, and supported with real data. It's it can be measured, and it's not based on speculation, okay? Accurately measurable, should be measurable. Again, can be normalized, okay? That means the value can be related to the total, okay? So these are the key attributes for the parameters involved in building a metric, okay? For example, here we are talking about, identifying parameters needed to develop performance metric for a traffic safety project. So we started with number of accidents. That's an indicator for the performance of the traffic safety projects, okay? Number of fatalities, for example, okay, due to accidents. That's another good indicator. Number of fatal accidents relative to total accidents. Here it reflects the severity of the accidents, or percentage of severe accidents. That's also, we can consider it as an indicator. Number of fatalities per capita. That's good because it's normalized. It's divided per person. So this way we can compare values, from one country to another country, from one province to another province. Okay? So it's independent of the population. Number of fatalities per mile traveled. That's even much better because it links the fatalities and accidents with the exposure to accidents. Okay, the more miles you travel, the more exposed the person is. Okay, so this even is better indicator. Both of these are the internationally recognized indicators for traffic safety performance. Okay. Another example we discussed yesterday, which was basically identify parameters needed to develop metric for speed enforcement projects. And in order to do that, we need to have a before and after data. Then, based on the before and after data, we can calculate the percentage reduction in average speed. That's a good indicator because the objective of speed enforcement is basically reducing speed. Okay, so this is a good indicator for this objective. A reduction in the 85th percentile of speed. That's almost similar to this, but here we are talking about the average. Here we are talking about the 85th percentile. Okay, a reduction in number of speed violators. Again, that's a good indicator. However, this one is not normalized. Okay, but here if we divide it by volume, by traffic volume, we get the percentage of violators. Okay, so that's also a better and normalized indicator. Let's check the list. Does these factors reflect project objectives? Yes. Is it quantitative? Yes, because it's speed. Is it measurable? Yes, we can use speed gun to measure it. Is it can be normalized? Yes, by dividing by volume or dividing by the number of observations. Here, we're taking the average. So this is a good indicator. Again, we can do the same here. Number of accidents, number of fatalities. Okay, this is reflecting project objective. Are these quantitative? Of course. Number of accidents can be counted. Number of fatalities can be counted. Measurable? Yes. Normalized? Yes. Can be divided by capita or divided by miles traveled. So these are, it's good to have this checklist to check against. For example, here, developing a metric for transportation network improvement project. Here the situation is different. So we can have a change in average travel time on network links. Okay, so here, is it reflecting project objective? Yes. I can add here also another measure. A change in OD travel time. Okay, it's reflecting project objective? Yes. I'm sorry. Is it quantitative? Yes, because it's time. And here also it's time. Is it measurable? Yes, we can measure the travel time for specific OD. Is it normalized? Okay. Now, how can we do this? Change in OD travel time. We can, divide it by number of trips. Okay, so the change the change in OD travel time, it can be added to average. A change in OD travel time. If we calculate network wide for the entire OD matrix, okay, and even we can have it here weighted average. So this way it's normalized, it's reflecting the entire population. Okay, so that's another example of that, of good indicators and good parameters that we can use in developing project metrics. Now we go to the second point, which is basically the structure of the metric. Okay, how we can structure it. First of all, the project metric structure is basically the mathematical formula that link the key parameters to form the metric. The project metric structure key attributes. It should reflect relationships between performance and the parameters. Logical and easy to understand. Okay, portable, i.e., not data specific or site specific. So that's very important, the portability of the structure. So here it reflects a relationship between performance and parameters. For example, if you go here, try to define the performance for metric of, so we can say performance here, for example. Okay, or let's call it KPI, key performance indicator, KPI equal delta fatal accidents. Okay, because basically this indicator, the higher, okay, the higher the performance. Clear? So if the change is significant, that means the key performance indicator or the structure, so it's directly proportional. Okay, so here the performance directly proportional to the change or delta in fatal accidents. If the delta, okay, negative, increase by reduction, that means the performance is improving or there is a higher performance. Okay, so it reflects a relationship. Is it logical and easy to understand? Yes. Is it portable? Okay, here it's this in this form. It's basically location specific, but if we divide it by population, then it's normalized. Then we can say this is acceptable. So here the KPI or the key performance indicator equal delta fatal accidents divided by population, or delta fatal accidents divided by miles traveled. Okay, so either way it becomes portable. Okay, so we can compare whatever the performance indicator in the eastern province with the western province, with the north, with the east, because you are dividing per population, per capita. Here, develop different structures for performance metrics for speed enforcement project. Again, we can say that KPI, the key performance indicator, it should be proportional to, for example, inversely proportional to number of violators. Okay, so the higher the number of violators, the lower the performance. The lower the number of violators, the higher the performance. Okay, or we can use this is kind of, logical, but it's not easy to understand by everybody. But we can say that KPI proportional to percent reduction percent reduction in number of violators, speed violators. Okay, it's easy to understand this way. It reflects relationship between performance and the parameter. Yes. Is it portable? Yes, because it's a percentage reduction. Okay, so here the KPI equal before number of violators minus after number of violators divided by volume per link or hourly volume. Okay, or divided by before number of violators. So that's another form. Either this or here you are dividing the drop per the volume on the highway, and here the before and minus after divided by the before. So that's another form. or another structure. This is another example also for develop different structure for a performance metric for transportation network improvement projects. Okay, so here we can say the KPI or the key performance indicator is proportional to what? To change or delta travel time. Okay, so this is reflecting relationship. Okay, is it logical and easy to understand? Yes. Is it portable? No, because maybe there is a, you know, the change in travel time, that's a numerical value, so it should be linked to reference point. So here, for example, delta travel time divided by or delta, or the change in average travel time between OD pairs divided by travel time, average travel time for OD pairs. This way it's portable, so we can compare, you know, before and after. But if we you know, if we don't include the division per average travel time, then there is no, you know, there is no point, just a value. So you cannot compare, for example, a network with another network. Clear? Okay. So now we move to the validation. How can we validate project metrics? How can we make an assessment and validation for project metrics? Can someone suggest for me how can we do that? شباب.
معك دكتور معك.
Okay.
Yes, doctor.
Yani, do you understand what I mean with assessment and validation? You come up with a metric. How can we tell if this metric is a valid project metrics or relevant? Is it based on your own judgment?
No, in the for the result, doctor. Based
Not
on
for the
result.
result. Now you are coming up with a metric for, or the key performance indicator for a project, transportation project. How can we judge that this key performance indicator is valid performance indicator? يعني مثلا yesterday, okay, when we were talking about you know, parameters or key parameters for transportation network improvement, some of you were saying reducing reduction, you know, no, for the safety, I think. Some were saying, okay, number of lanes, okay, and, you know, congestion. If we eliminate congestion, then the highway will be safer. We will not have enough. We will not have, you know, severe accidents. Right? How can we make sure that we are not selecting the wrong indicator? Can someone suggest to me?
We look for the capacity for road, maybe.
Now you are talking about something specific, Asim. Okay? Okay, here are the steps or the different approaches to make an assessment and validation for project metrics. First of all, acceptability. So we have to conduct a survey on stakeholders and decision makers to see how much they are accepting these performance indicators. Okay, because basically those are the ones that are going to be using these metrics to measure the progress of the project. Okay, that's one. Number two, concurrency in estimations. What do we mean with concurrency of estimations? Now we were talking about the parameters used in the project. It should be quantitative, measurable, normalized. Sometimes maybe there is a mistake in the quantitative issue and it's difficult to measure quantitatively. So sometimes we have to make an estimation. Okay, and at this point the KPI should be concurrent. What we mean with concurrency in estimation? Concurrency in estimation, that means if Qusay is conducting this KPI and making an assessment for this KPI, will come up with value. Then Jasim will come up with the same value or almost identical or close to that value, and Abdulaziz will come up with the same, and this means the different estimator will result in similar values. Okay, then means this metric is valid and usable, because different people, when they apply it, they come up almost with the same value. It's not necessarily that you come exactly with the same value. No. But if you make the estimation and apply this key performance indicator, you will be more or less within the same line. Okay. Then there is also the portability test. Try to apply it in different sites and evaluate the results. Okay, for example, the highway capacity manual, okay, performance measures. Example, the method for delay study at traffic signals. Okay, this method was developed in the US and based on data in the US traffic flow, but it was not based on a single site. It was based on numerous large number of sites. So when we apply it here in Saudi Arabia, we come almost with the same result. That means this method to measure delay is portable. It's not for the US only. You can use it in the US, you can use it in Saudi Arabia, you can use it in UK, in Australia. Okay, so that's the issue of portability. It's not just fix it for a specific geographic area. Okay, guys? Okay, so that will conclude our topic for today. And I think this is going to be our last lecture in the course. Thank you, and hoping to see you in the next course, inshallah.